guys, today we're going to do a Minesweeper game, and I think most of you will know the rules, so there's really no point in going over them. If you don't, however, you can just Google them, so I'll just get to the code. Create new package, code Minesweeper. Sweeper app. We'll extend JavaFX application, and this is going to be our entry point. So the usual launch arguments. Stage show, stage set, scene, which is going to be a scene. New scene, create content. And our create content method, which returns the root of our application, which is going to be a pane. We'll set preferred size 800 by 600. You can tweak the size if you want to. The game essentially consists of a grid, and we'll need to choose grid or tile size. I'll do 40, should be alright. The number of tile, X tiles. So basically number of tiles in X direction. 20, because 20 by 40 will give us 800. Or actually, what we could do, static final int w for width, and h for height. And then we can do just w divided by tile size. Y tiles. This is number of tiles in vertical direction, vertical orientation. And we'll also need, we'll need to define our data structure for, it's going to be a data structure plus view in the same class. So it's going to be a tile, which extends stack pane So each tile will have X and Y value, which are going to be coordinate values. Plus we're going to pass a boolean to signify if it has a bomb or not. So each tile could have a bomb. So int X, Y, and boolean has bomb. As for the graphics, or the visual part, we are going to create a rectangle, which is going to be a border for our tile. So border, new rectangle, tile size -2, and tile size -2. So it gives us a square. And we are subtracting 2 because we're going to put, we're going to add a stroke. And stroke width by default should be 1. Yep, it is 1. So we have stroke from both the sides, which gives us 1 multiplied by 2 gives us 2, and hence the tile size minus 2. Stroke color light gray, I think should do, and if we do the background set fill color black, well, it's black anyway by default, so it should be fine. Obviously those colors are modifiable, so if you want to have slightly different look of the game, you can modify them on your own. Border, what else? We need a text object to display, I know, value. Actually, let's call it text. Make sure you're importing JavaFX stuff. Text, if it has a bomb, then text, set text, has bomb X, if not, nothing. So we'll need to add those things to the children on stack pane that we are extending. So order comes first, then the text. We also need to set translate X and Y, so basically position the tile, which is X multiplied by tile size, and translate Y multiplied by tile size. That should do for now. We also need to be able to track the number of bombs around each tile. So we'll also have a field value and bombs. So this will be number of bombs around that tile, which we should be able to set later, because we first need to populate the grid. And even before that, we need to actually declare our grid. So tile, so it's two-dimensional array, tile, X tiles, and Y tiles. For int Y, so we are going, this is the vertical loop, Y less than Y tiles. For X less than create new tile XY. I will also need to pass if it has a bomb or not. We're going to use math random. It gives us a value between 0 and 1, so if we do something like this, it should be around 20%. So 20% of the time there will be bombs spawned on the tile. Tile, what else? We also need to assign that tile to the grid. And we also need to add this tile to the list of children of the root, so it can be added to the same graph and later displayed on the screen. It should be alright for the population. Then we need to, so this is the next time we're going over the tiles, and we are going to count number of bombs so that we could set the value of bombs. X, Y. Set bombs. But for that, we need to know neighbors of each tile. So we'll probably need to have a different method which delivers us a list of tiles. Get neighbors. Import that list, and we need to pass in a tile so we could get neighbors of that tile, which we can do by First of all, let's define a list. Neighbors. We need to import array list, and then we're going to return that list of neighbors. First, we need to obtain x and y values of neighbors. So let's do an array first, which will contain all the dx and dy values relative to the tile we're given. And we'll have 8 neighbors, 3, 3, yeah, that's 8. So 3, 3, and 2 from left and right. So we'll do -1, -1, that's top left neighbor. Then -1, 0, that's to the left. -1, 1, that's bottom left of that tile. So imagine you have something like that. I'll use T for tile. So tile, 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 X, which is the current tile that we're given here, T, T, T. So the X is the tile that we're given, and we need to obtain a list of neighbors, and the neighbors are all those T's that we want to add to the list. And each of those tiles will have their own x and y value, which we can obtain by subtracting or adding 1. So we've basically calculated the whole left part. So we're going for this one and that one, which is -1. Actually, no, it's 0 and -1. 0 and 1. Then the right part, this, that, and that one, which is 1, -1, 1, 0, and 1, 1. Now for all those values, so I less than points length, we first get dx, which is that, so essentially starting from 0, which is points with index I. As for dy, we are going to pre-increment and then take the index. So this dx will be assigned -1. When we come to dy, we are going to increment the index to the array and select that. So it will increment and then select. When the loop ends, it will auto-increment the index, so next time we start, we're going to start from the new x again. So this works. dx dy. Now we need to get new x, which is the neighbor's x coordinate, which is, we get tile to start with. We obtain its x coordinate. I'm not going to do public accessors and stuff because it's in the same class, so I can directly access private fields, just for the sake of this tutorial. But you, on the other hand, if you're writing this in a different class, then you will need to provide public accessors, getters, and setters and stuff. New y is tile y plus dy. Because we already have minuses here, we don't need to worry about them. We also need to check whether new x and new y is actually a valid coordinate within that grid, because it could be, so for example, 0, 0, we get a minus, that will be a -1, which is not a valid index to the array. So we need to check if the new x and new y are valid. We can easily do that by checking if new x is greater or equal to 0. That's the lower bound. And new x is less than x tiles. We cannot have x tiles because we start counting from 0. So it has to be tiles, x tiles minus 1, which that thing gives us. As for y, it is similar thing. New y is greater or equal to 0, and it is less than y tiles. This could be replaced by a method. You could name that method isValidCoordinate or isValidPoint and use that instead. And if it is, then we can add that tile at that position, which we can obtain from the grid, new x, new y. That should be enough for getNeighbors method. Yeah. So now we can use getNeighbors method to calculate the number of bombs. I'm using long because the stream count will return long. GetNeighbors tile stream. This is sort of kind of functional way of doing it. Filter tile. Tile has bomb count. So what we've done here, we've obtained a list of neighbors of that tile that we're going through. We've obtained a stream of elements. Then we've filtered those elements, so we're filtering neighbors. If the neighbor has a bomb, then leave it in the stream. If not, then discard it. So at this point, we're only left with neighbors which have bombs. So we just count number of elements in the stream, which returns number of bombs that we need to set to our tile as a value. Do we even have method? It says bombs, right? So tile bombs. Or we could just access text directly, so we don't need to do this. We'll just do tile text set text string value of bombs. So that will set numerical value to the text that the tile has. And that should be it, really, at least for the initialization process. So if we run this, okay, so text is black, so we need to change the color of text. Set fill color white. So we now have oh yeah, we also need to skip those which have bombs. So if tile has bomb, then continue. So where you can see, actually you probably can't see anything, so I'm going to increase font, set font to font 18. Yeah, so where you can see X says these tiles have bombs around them. We've calculated number of bombs around a particular cell. So if this cell says 2, it means that if we take a list of neighbors in those neighbors there will be 2 tiles, 2 cells which have bounds. Now we need to be able to open them dynamically, so within the game. And so each tile by default will be closed. So billion is open false. We'll also set text visible to false. We no longer need set fill white because we're going to change the color of the background when we open it, so it's clearly visible. Open. If is open, then we need to return because we don't need to do anything. Else we need to set is open to true. Text set visible true. Rectangle, actually it's border. Set fill null. And what else? Actually, in the original game, I think if it has 0 bombs around tiles, it doesn't even display it. So if bombs more than 0, then display the value or set the value. If it has 0 bombs, then it should be automatically able to open adjacent cells which also don't have bombs. So if text is empty, so if it has a bomb, it will have an X. If it has a neighbor which has a bomb, then it will have some sort of value, meaning that a 0 value will not affect the text in any way, so it's going to be empty. We need to obtain neighbors of this tile, and then for each of the neighbors, tile open. That should work. And we trigger open on mouse click. So on mouse clicked. So when we click on a tile, it now sort of opens from the closed state. By default, it is created as closed. The text becomes visible. The borders fill color, which is black by default, is nullified, so it's going to be transparent. And the value should display number of bombs around in adjacent cells. So if it says 2, then in any of those cells there should be a bomb, or at least 2 bombs, yeah. So X is where you can find a bomb. And yeah, if you click on a space which has no bombs and adjacent cells also have no bombs, it will recursively open them because there is really no point in hiding them. So because these are open, there should be a bomb here. Yeah, there is. Right, so this appears to be working. Last thing, I suppose if we click and we open, and if it has a bomb, then I know do something. If has bomb, and it'll just print something. System that out. Actually, we could start a new game, I suppose, because it's just the grid. So we could take the scene reference outside, and we can do something like this. So if it has a bomb, then we're going to print game over, scene set root, create content again. We should really clear the root before doing that, but it's fine. And return. So if we find a bomb, the game should restart. The first thing I clicked was a bomb. And again. Yeah, so that should be a bomb. If I click on it, the game should restart. Yep, it did. So it appears to be working. If you find a bug, just leave a comment or fix it yourself. You can also change colors and add score or something and make it look like an actual game rather than just logic and stuff. And yeah, this will be it for this tutorial, and thanks for watching.